little setup for today. Briefly about myself, if you're unfamiliar with me, I'm the Director of Education at GBES, Green Building Education Services, and I like to host these live webinars at least once a month to bring you the latest and the greatest knowledge about our industry, right? So green and healthy buildings. And earlier this year, I had the wonderful opportunity to participate in a WELL version 2 roundtable here in Atlanta. And that's where I met and became friends with Octavio. He was another participant in the roundtable, and we were giving some real world consumer feedback on the development of the rating system. Super awesome opportunity. Was actually hosted in a WELL building, and it's just one of the great opportunities to get involved with these rating systems, get involved with these organizations, and stay active in transforming your community. So I've already got one question coming in that I'd like to answer real quick from Arun, and they say, is this session entitled for any WELL CE hours? And the answer is you may self-report this course as a general education hour. So if you are a WELL AP and you are maintaining that credential with continuing education, please do self-report this course as a general CE hour. We don't have it yet approved for WELL specific, and we will let you know if and when that happens. So at this point, I'd like to just introduce my guest here, Dr. Octavio Perez. He has been focusing research in a medical environment on human-centric lighting. And this is just a topic that draws up a lot of questions. It's in the WELL building standard, and a lot of us are scratching our heads trying to figure out, what does this really mean? How do I actually implement it in our building? And so Dr. Octavio is here today to help illuminate how and when to design for circadian lighting. So with that, Octavio, tell us a little bit more about yourself and what you're going to teach us today.
Okay, thank you, Alyson. First of all, thank you to you and to all the audience for being here. I had the great opportunity of do my doctoral research with NIH funding, the National Institute of Health, at Mount Sinai Hospital in New York City, while I was at the Rensselaer Polytechnic Institute. And now I'm an active researcher at the hospital and an international consultant in the field. We will see a little bit before starting the presentation about the environment, the research environment that we have at Sinai. And I have also included a couple of slides of real environments where I'm working on, so that you can have like this real world hands-on approach. And then if there's any question, you are more than welcome to ask it. So I'm ready whenever you are ready, Alyson.
I'm ready. Why don't you show us the slides?
Oh, okay. So let's go ahead. And then just, I guess that no one is seeing like the camera and this other on the right side, only the PowerPoint, right?
I see your face and I see the title slide that says human-centric lighting.
This is what you see?
Yes.
Okay. Let me then close this one. And then let's go through the presentation. So the title of the presentation is Human-Centric Lighting, and what we are going to focus is in circadian lighting design, that is feature 54 of the WELL building standard, and we will do it from a translational approach. This means that we are not going to speak here about basic science, and the main difference is that basic science is like about the signals, the light wavelengths that produce like a certain stimulus and associated effects. But we are going to see here like a wider approach and in a real world environment. So let's go through it. And here we have the index of what we are going to cover. So the first thing is that we are going to define what is this about human-centric lighting or integrative lighting. That is a term that the CIE has just introduced. Then we will speak about the environment, the expo zone. That is a term that was introduced like 15 years ago, and that I'm using as to incorporate light and lighting as an environmental health factor. Then we will speak about the interaction of lighting and buildings. So how we put the light at work on the architectural spaces. And in particular, we will speak about well-building standard circadian lighting design, that is feature 54. Then we will briefly discuss about technologies and design strategies to achieve human-centric lighting. We will discuss finally there's a very important topic that are the ethical issues. So what do we have to consider when, as for the people, when we implement these solutions? And finally, we will wrap up with conclusions. So before, Alyson, I guess that you wanted to ask a couple of questions before going further.
Yes, so I'm going to issue another poll. So we know who's a WELL AP, but we also want to know how many of these lighting terms are you familiar with? So you can select one or all. If you don't know any of them, select none of the above. But this is just to figure out where we at in our understanding of lighting. So think about, you know, building interior lighting, right? Lighting for illuminating workspaces. Have you used these terms before? Are these concepts something you could explain to another person, you know? And hopefully by the end of this webinar, you will have a lot more confidence about these terms, and you will be able to speak about them intelligently and perhaps even educate some of your peers about these. So if you don't know any of them, that's okay. You're in the right place because we are going to teach it to you right now. So I've got 75% of the audience tuning in and responding. So let's share those results. It looks like most of us have heard of circadian lighting design before, so that's a great thing. Some of us have even heard of human-centric lighting, but only less than half of us are familiar with integrative lighting and the melanopic stimulus, or EML. And Octavio, 20% of the listeners don't know any of these. So make sure you provide some good definitions of all of these going forward. And again, the outcome is to get familiar with these. So don't worry, you're not behind. This is just letting Octavio know how in-depth to explain these things.
Okay, so let's move forward with the presentation. And here we are going, and before I want to introduce you my team at the hospital and our facilities and the lab, and then we will go into the real index. So these are my team partners, all of them related with the medical field. And we also work together with facilities management, healthcare informatics, leadership, and innovation at the hospital, because we have to implement these solutions in real spaces. So as for the lab, here you can see how it looks. It's at an emergency department simulation room where we did a lighting intervention in 2015. And as you will be able to see now, we are able to change not only the spectral power distribution in relative terms and in power, but also directionality, so that we can work under different environments. Here you can see that we can shine light upwards and downwards, changing the spectrum. And very important is that we did ourselves this installation. So here you have the lab as it was in 2015, and we were testing the fixtures, and we began, because this took a long time to do it, we implemented here all the controls and all the lighting devices. And also very important, I designed the control and the electronics so that we were able to have 0% of flicker. That is very important in human-centric lighting, because most of the devices that are in the market, they produce one or another kind of flicker. This was with 0 flicker. Basically, what we do is we have different channels, different LEDs in wavelengths. And then what we do is with this is we compose light as if you were composing music with a piano. And then through the control system, we are able to achieve the spectral power distribution that we desire for the experiments. So here you will be able to see what we do. On the top, you have the spectral power distribution of regular fluorescent lighting. At the bottom, you have one of the spectral power distributions that we use. And here is how it looks under different lighting conditions. And then we study how clinicians perform in the different environments. So what is very important is that we are speaking here about not only about light, but also about people and about activity. And we are also monitoring indoor environmental quality that is in synergy with well feature 18. And here you can see the display that we use for this purpose. And there we monitor carbon dioxide, temperature, and relative humidity. We got an innovation award at Mount Sinai that is called 4D. And then we also, and this is very important because I think that this is the first time that it has happened, that we were shortlisted for the lighting design of our research environment for the Dark Awards in London in 2016. So with this, I think that we are ready to go into the index and go into the terms. So the first one is going to be what is human-centric lighting and what is integrative lighting. Many people are speaking about it, but there are not that many definitions. So the first one is how to define human-centric lighting. And as far as I know, the only official definition that we have is this one that comes from Germany. But I guess that this is a difficult one. So let's focus in another term that is integrative lighting that was introduced last year, a couple of years ago by the CIE, and is that lighting specifically designed to produce a beneficial physiological and psychological effect upon humans, including both visual and non-visual effects. So this is the definition that we are going to have, so that all these people that were not knowing what is integrative lighting, here you have it. This is the reference. And what is very important is that light and lighting are different concepts. And the way I understand lighting is about the art and science of delivering light. So what's the implication of this? The main one is that lighting is not only light. And this is why I was differentiating at the beginning, to be careful with basic science. So we have to be very careful with all the studies that have been done with mice and all these other studies that have been done with like chambers where you stay there like for a couple of hours without moving your head, because this has nothing to do with the real world environment. These are light studies, these are not lighting studies. So when we go into lighting, we have to consider the light and the environment. So at least we have to take into account directionality, timing, the space. A couple of pictures. In this one, Alyson, I guess that you recognize yourself. You are on the right side. This was Atlanta. This is a well space. And so what we always miss here in the studies is the beholder, the person, and the activity. So wrapping up, it must be very clear that light is the primary stimulus in human-centric lighting. It's the spectral power distribution, invisible radiation, but we should also include ultraviolet and infrared, the technology, because we have to count here with daylight and electric light, both. The environment as the affordance vehicle, and when I say the affordance, is the media that provides us the lighting. So here we have to consider directionality, the reflectances of the walls, ceilings, furniture, walls. So we have to take into account the space. And very important, the beholder, the person, as the recipient of the stimulus. So the accumulated exposition, what I will define as the exposome, is very important. The biology, time of day, the season of the year, the mood and stress of the person, the memory, the culture, all the social interactions. This becomes very important. So human-centric lighting is not only light, it's light, environment, beholder, and activity. So if we go into the environment, here we will introduce this term, the exposome. And the exposome can be defined, at the bottom you have the link if you want to look further. Can be defined as the measure of all the exposures of an individual in a lifetime and how those exposures relate to health. This is very important because genetics is only responsible for about 10% of the diseases in humans. So the remaining disease causes come from the environment. So we have to know how the environment is affecting us. So the question here is, can we consider visible light as a factor of the exposome? And if so, we have to be able to accurately measure exposures and effects of these exposures. Okay? So at this point, Alyson, I guess that you want to do another follow-up here.
Yes, thank you. And I actually wanted to clarify something that you presented in the first part there. This question just came to me. Are you using human-centric lighting and integrative lighting interchangeably? Are they the same thing, basically?
Yes, they are the same
Okay.
term. I mean, you can speak about one or the other with no difference. Yeah, it's
Okay.
that integrative lighting is properly defined. I mean, I don't want to say that human-centric lighting is not properly defined because it is in German, but integrative lighting is in English and is published by the CIE, and this is like the main authority for this field. And I think that it is always a good idea to stay into standards because otherwise we begin to speak about terms without clarification. Okay, but yeah, you can use both, no problem.
Thank you. That's what I was trying to clarify, because a lot of us responded to the poll saying we were familiar with it, but then the only definition was in German. So I think it's one of those ideas, right, that it sounds like we should know what it is, and you're giving us a very clear definition now. So thanks for that clarification. The next poll question is, so this is just to kind of identify if you took in the lesson that we just received here. So is light the same as lighting? Octavio just told us the answer to this, and so this is just a quick little double check. Are you following along? And you know, this is interesting because as I was preparing for this, I really leveled up my lighting understanding and realized that I may have been misusing some of these terms. So thank you everybody for responding to the poll. Honestly, 96% of us said no, and some of us might still be confused, but that's the correct answer. Light is not the same as lighting. And we have one more follow-up that I'll post. And Dr. Perez, do you want to just add anything else to help us remember why light is not the same as lighting?
Yeah, a quick review. As I said, lighting is the art of delivering light in real environments. So light is just the stimulus, like the starting point. But then we have to be very careful with considering the environment, the time of day, season, and the persons and the activity that they are performing. So the same stimulus in different environments, different persons, different activities may have a totally different effect. For example, and I don't want to go too far in this question, but as you know, blue light has become now a very popular topic. Without going into the health implications, if you use blue light, blue enriched light around 480 nanometers in the morning, this can wake you up and can be very, very beneficial for your circadian rhythm. But if you use the same stimulus at night, it can be very detrimental for your sleep. So we have to be very careful with timing. So also, as we will see later, the way we receive the light, either from the upper side of the retina or the lower side of the retina, will have a different effect. And the architectural space is providing this to us. So this must be very clear for people doing human-centric lighting, that it's not only about the light source or the lighting fixture. It's the integration into the architectural space and the consideration of the person and the activity. Okay?
Thank you. So that brings us to our next poll results. Talk us through this question. Which of the following factors are important to light? I think you just said basically all of them.
Yes. Mm-hmm.
Got it. So the big takeaway here, folks, if you need it said in another way, that human-centric lighting is not just about picking a bulb and installing it everywhere. You have to consider like all of these factors, especially the people and the activity and what they're doing and the directionality. So awesome. I think we're all following along. So please continue. Tell us what's next.
Okay. So next is just a little introduction here about buildings and architectural spaces, the relationship with lighting, and then we will go into circadian lighting design of the well building standard. So first, about buildings and lighting, it's very important that all the building standards and codes recognize lighting as a critical factor in two different areas. First, in energy, and here we have a standard like LEED. And second, in human comfort, health, and well-being, and here's where well comes into place. Something that not so many people consider is this rule that is like the 1990 about the operating cost of a building. And if we do the estimate for 30 years, we can consider the average lifetime of a building, we will see that energy is only 1% of the total cost over 30 years. Then we have rental and equipment that can go up to
Thanks for your patience as we get over this technical glitch. But hopefully what you're seeing here is that we're trying to start talking about the life cycle, right? So you should be familiar with this from LEED, a building operating life cycle. this is where we look at what is that ROI, return on investment, over operating this building for 30 years. So the total cost, really only 1% of that is going to our electricity bill. 9% of that, that's like leasing the space and maybe computers and all that other stuff. And what you're about to see is that 90% of it is actually the salaries, the healthcare, the people. That's what that big cost is the people. So the takeaway here is that it is valuable to invest in where the greatest amount of your money is going, right? So just follow the paper trail, follow the money. If 90% of that is going to your people, let's make sure that we are taking care of the people the best. So it looks like, unfortunately, we lost Octavio for a moment, but I can share the slides here. And let's see if we can just mouse through them. I'll open this in Drive.
Hello?
Hi, Octavio.
Yeah, I'm here. It was a problem with the flag. Don't worry. I didn't run into the beat. No, not a problem. Okay, let's do yeah. So sunny day today.
I was trying to bring back up your presentation, but I couldn't get it off the title slide. So I'm just going to pass the controls back over to you when you're ready. If you can bring that back up and just recap what that 90% is about.
Yeah. So are you seeing now my screen?
Yep. I just see the building operating cost, no images yet.
Perfect. Okay. So we were here, and then what I was introducing is that everyone is now very busy speaking about energy, and energy is really important. But the total implication in 30 years is just only 1%. Rental and equipment goes up to 9%. And very important here is that people, the occupants of the building, represent 90% of the cost of the total operation of the building in these 30 years. This means that if we go into improvements, if we do a 10% improvement in energy, the impact that this is going to have is 0.1%. But if we do this 10% in the people, this is going to be 9%. This means that whatever we do in the people will be much higher than whatever we do in energy. This doesn't mean that we have to forget about energy. It means that we have to concentrate more in people and in health and wellness implications in the buildings. So here is where Well enters into the market in 2014 as the only building standard focused in human health and well-being. The version 2 of the standard has been recently introduced by the end of May. And as Alyson said at the beginning, we are Well APs, well accredited professionals. Well has 7 concepts: air, water, nourishment, light, fitness, comfort, and mind. And light is one of them that has 11 features. From these 11 features that we have here, 4 of them are preconditions, and the other 7 are optimizations. And what is really important is that, and this is why I began with Well already 3 years ago, is because it's the only standard that introduces circadian lighting design that accounts for this. So let's go into what is Well doing with this. Well recognizes that we have human circadian rhythms. It's not only that we have energy in the buildings, we also have people that have rhythmicity. And very important is that light and lighting are the main drivers for the human circadian system. The iPRGCs that are a special group of family of cells that were discovered in 2001, 2002. These are like the main mediators of this effect of light and lighting in our circadian rhythmicity. The way we measure it, if you remember from the exposome, we have to be able to measure things. The way we measure it is through the melanopic stimulus. That in well is the equivalent melanopic lux, well version 1, and in version 2.1, another metric has been introduced that we will see in the next slide. Then we have models and calculations to account for this metric. And then very important, we have to do the performance verification that we do as a post-processing phase. So first we do the design, we do the commissioning, and then we have to check that everything is working according to our expectations. As the circadian lighting design in well, this is in version 1 is feature 54, and in version 2.1 is L03, and another metric has been introduced that was introduced in the European Union last year, and that has been published officially by the CIE on Thursday last week. That is the melanopic equivalent daylight illuminance based on the D65 standard from the CIE. So if we go into version 1, we have two ways of achieving this feature in well through EML, and that I call EML 200 and EML 150. And in version 2, this new metric has also been introduced that is described in these two standards that you have below in case you are interested in knowing more. And then in version 2.1, there is a difference between electric light and daylight, but I'm not going to enter into this. We are going to focus in version 1. In version 1, option A is what I call EML 200, and this means that at least 75% of the workstations need a minimum of 200 equivalent melanopic lux on the vertical plane, 1.2 meters facing forward. And I put this stand up because well also promotes dynamic workspaces. This means that you can be sit or you can be standing up. And in version 2, this has been corrected so that what you have to measure will be 45 centimeters above the work plane. The time, very important, as we discussed before, is 4 hours in the morning, 9 to 1 every day of the year. And this calculation may incorporate daylight. EML 150 is the second option to achieve this feature, and this requires in 100% of the workstations to have a minimum of 150 equivalent melanopic lux, same as before, but maintain. It has to be during the whole day. And it only considers electric light. And very important, it may include task lighting, so personalized lighting. How do we calculate this EML? The way of doing the calculation is in two tables in the standard. One is table L1, where the melanopic ratio is described. Before, there were some tabulated ratios, but this is totally inaccurate and it has been deleted. So the way of calculating this melanopic ratio of the EML is to measure the visual illuminance in lux and multiply it by a ratio between the equivalent melanopic lux and the standard visual illuminance. How do we calculate this ratio? For this, we have another table that is the melanopic and visual response. And then we need either we have to measure it or we have to get it from the manufacturer of the devices. We have to obtain the lamp, not the lamp, but the fixture spectral power distribution in this range. Very important, one thing is the spectral power distribution of the fixture, and another one is the environment. So this about the fixture will only give us an idea, but we have to estimate the effect of the environment. Once we have this, we go into this formula. I'm not going into this detail. And once we do this, we can go back and measuring photopic illuminance, we will be able to get equivalent melanopic looks. This was before, but since a few months ago, there is equipment in the market, and here I just want to show two of them that will give us direct reading of equivalent melanopic looks. And in the case of the first one, it will also give us the melanopic equivalent daylight illuminance. So here you have them as a reference. And these are very affordable. Both of them are below 2,000 US. And in this new photometry, you have to forget about looks and go into this kind of devices that measure the real environment. So I guess that you have here some more questions, Alyson.
Yeah, we sure do. So hope everyone is following along. Our next question is kind of a true-false. Which of the following statements are true? So there's only one correct answer here. Read it carefully. So these are a little tricky, but lighting is not a critical factor for building. You should consider circadian lighting design in LEED. Energy efficiency is not considered in WELL, or EML is not a metric for circadian lighting design. So which of these following are true? And hopefully, Octavio, you can talk us through why the other ones are not true, because this may be a little tricky. And one question, while we're still waiting for at least 50% of us to respond, if you haven't taken a guess yet, just take a guess. You might be right. This isn't being graded. But the question just came to my mind, and I'm sorry I didn't prep you with this one, but when we're talking about equivalent melanopic lux, what does it mean equivalent to what? Like, this is trying to say another way to represent lux, or can you break that down, what that equivalent is referring to?
Yeah, let's go into this into the melanopic equivalent daylight illuminance, because the term EML has been superseded already by the CIE. The melanopic equivalent daylight illuminance, simplifying the explanation, will be how many melanopic lux is providing a certain environment or fixture compared with the same illuminance provided by a D65 source. So we are comparing here to daylight 6,500 K, the standard definition of the D65, and then we compare the ratio between the environment and this one provided by D65.
Okay, so you're comparing it to kind of how it shows up under daylight?
Yeah, it's like trying to compare the environment with daylight. So daylight provides a certain stimulus, and we want to see which is the stimulus of this spectral power distribution compared to daylight.
Okay, that answers my question. Thank you for that. So let's share these poll results. No one thought that lighting is not a critical factor in buildings. Is that correct or incorrect?
Oh, yeah. Yeah.
Okay, so lighting is a critical factor. Good. Yes. How about considering circadian lighting in LEED? Is that true?
No, you don't have to consider it. It's not part of the LEED standard. LEED considers daylight contribution, but it doesn't consider specifically circadian lighting metrics.
Okay, so that's one of the big differentiators between LEED and WELL.
Yes.
Okay.
As I said, WELL is the only standard that recognizes circadian lighting design with metrics.
Okay, and so then the third one, energy efficiency is not considered in the WELL standard. That's a true statement, correct?
Yes, this is the true one, because as I said, WELL is focused in human health and well-being, and even if it has synergies with LEED, by itself, it doesn't consider energy efficiency.
Got it. So that's a good clarification again between the two standards and why they complement each other and why a building can pursue both. And then the fourth one, EL is not a metric for circadian lighting design. That's false because of the word not, correct?
Yes. Mm-hmm.
So EML is a metric that
it is. Yeah,
WELL currently uses.
Mm-hmm. Yes.
Okay, thank you very much. Any questions from the audience on that? I'm really glad we have some little check-in questions to measure your progress. So for anybody who's listening live with us, let us know if you need follow-up or in that while we're here live. That's what this is all about. Chat me over your questions. I'll be asking to Octavio when he's done with his presentation, which I believe is wrapping up. So take us your final slides on this presentation. What else do we need to know about human-centric lighting?
Okay, let's go through it. So I want to do here an example of this melanopic stimulus, and we will do it with a full spectrum system that I have developed. That is a task lighting based on Seoul sunlight LEDs. And here what we are going to measure initially is the horizontal illuminance. And what we see here is that we have to measure this at a certain distance from the ground. This in this case, 76 centimeters facing up. And here's where we place the spectrophotometer. Next that we have to measure is this vertical equivalent melanopic lux. And the way of doing it is 120 centimeters. This what you see on the right side is the opposite, but this is just for clarification. So it has to be at the eye level of the person at a certain distance of the fixture. This is only for fixtures. So in spaces is slightly different. This is for fixtures characterization by a lighting manufacturer. So if we go through this, we obtain these values, 561 lux, that is okay for European standards, that is 500, and more than enough for the US, that is 300. With this, we get a vertical illuminance of 343 lux. And if we go through the ratio that we have measured before, that is 0.912, then what we obtain is that we have 313 equivalent melanopic lux. That is more than whatever we need in any of the options that was either 200 or 150. So once we have this, what is very important is to go into these ratios to know how much illuminance do we need at the work plane for each equivalent melanopic lux. In this particular case, we need 1.79. And this is extremely important because this will tell us, depending on the environment, depending on the spectral power distribution of the, how we can optimize the illuminance required at the work plane to get the right illuminance at the eye. So here you have both. And this is the metric that I introduced last year at LPS 2017 in Bregenz in Austria, and that I have fine-tuned to introduce it couple of weeks ago at the Lighting for Health and Wellbeing conference in Newport Beach. So this is the ratio, how much illuminance in lux is needed at the work plane to achieve a certain amount of melanopic stimulus at the eye. This is extremely important, this kind of metric, as a lighting design, circadian lighting design performance. And then we can move forward with this about how much energy is needed to achieve this stimulus. It's not only about achieving lumens and luxes, but also about this circadian stimulus. And of course, we will go into the discussion about power density. So there are some limitations. I don't want to go in detail into this one, but basically biology is not behavior. They are based in melatonin suppression at night. Very important, this one, awakeness and focus is not alertness. Many people are only speaking about alertness. We don't want alertness in people. We want awakeness and focus. The age factor is very important. They only measure light at the corneal level, but they don't consider directionality. They are not easy to apply for lighting designers. And very important is that we are not statistics. So even if we can get these metrics, this will only give us an orientation. Here you have the difference in age and the spectrum that we get at the retina. So the main area of the spectrum is the short wavelengths, and this is where we have the melanopic stimulus. And if we go into numbers, we can see that we may need 3 times the stimulus for a 65-year-old person compared to a 21-year-old. So this is something that we will need to consider in the future. And also directionality of light is extremely important. Light coming from the upper side of our view will have a great effect as from a melanopic point of view. Whatever comes from the downside, like from the ground, is going to give a lot of glare. And this is what happens when we go to the sea, when we go to the beach, when we go to the snow. So this is extremely important. Light has to come from the upper side, and this is exactly what we have when we go outside in the sky. So now let's go quickly into technologies and design strategies. And these are just only going to be 2 slides. Technologies. This is a concept that is extremely important. A lighting system imprints light in an environment, same as a printer prints papers. So this takes us to the next, that is that lighting is not about fixtures anymore. It is about IT, it's about networks and about software. And for human-centric lighting to happen, a very important factor is that lighting procurement has to move from MEP, that is mechanical, electrical, plumbing, to IT, because IT is going to be able to appreciate and pay for this value, while mechanical, electrical, and plumbing is only worried about price. So 2 enablers of the technology will be power over Ethernet and Bluetooth, and these are totally associated with IT and not with electrical. Another factor that is extremely important is user interaction and user experience. These are like the main topics when you go to real life to implement solutions, and these are like the most critical ones with the users or with the persons that are in the spaces. They want to know how to operate these systems. And also that we are speaking here about the multi-channel systems, as you saw in my system at the hospital, that are going to do a dynamic delivery of light. We will see in the future, but I cannot go here into too much detail because of technology disclosure, into single versus double or multiple emissions. So we will have in the same fixture different emissions of light depending on what we want to achieve. And of course, that daylight is the preferred light source and full spectrum the alternate. So this is the most important one for this to happen, procurement. We have to move from MEP to IT. About design, Here we have to be careful because we have like to balance glare versus melanopic stimulus, and here dark lighting is not going to work for human-centric lighting, and I will show you an example later. So retrofit is not going to be real human-centric lighting design. So to put a fixture where we have an old fixture, and even if it does some fancy things with the spectrum, this is not going to be a real human-centric lighting design. We have to be very careful with moving from light points into light surfaces. In this sense, if we go into larger surfaces, we will lower the luminances, and then we will get less glare to the occupants. And extremely important, direct versus indirect lighting. So if we go into indirect lighting, the architectural space becomes part of the optical system of the lighting. Light reflectance value, that is feature 59, surface design, has a very important synergy, because if we have a high light reflectance value, we will get more light from the same device. So this is an indirect way of improving energy, but also we will have a more homogeneous distribution of the spectrum. And again, daylight is preferred light source, full spectrum alternate. So here you have an example of lighting design that I have implemented for a car manufacturer in the headquarters in Spain. And here you can see the surface is a whole ceiling, is not anymore a luminaire, like a fixture. And here we can change. I cannot go into the details of what we do with each setting, but as you can see, this is a real environment. You can see here also at Sinai, this is how the simulation center was looking before the intervention, and this is how it looks now. That is exactly as if you go you see here a sky, indirect lighting, you don't see any single light source here. And about dark lighting, this is the typical downlight where the light source is totally covered. So here you don't see it. When you turn it on, you see it a little bit, but if you go into detail, this is going against a black surface. So you don't get stimulus because you don't get light into your eyes. So very careful with this. Finally, we will go into the ethical issues. So is this only about do no harm that many people are discussing about? And I don't think so. We have to consider three: precautionary versus proactionary, real life scenarios, and that this is a multidisciplinary science field. So if we go into precautionary versus proactionary, precautionary is to do no harm, do not take risk. Proactionary is to do good, to go into innovation and progress. And my point of view here is that we may do more harm not doing than doing with responsibility. About real life scenarios, briefly, in offices, we can see that we can improve performance of the workers, but then if they are going to work more, are they going to be paid more money, or are they going to have more vacations? The unions are going to say here something, because the performance has been increased. About schools, we have to be very careful also in academic improvements versus inequalities, because if students in an environment where human-centric lighting doesn't happen will get lower results, that we have to consider if they have to be balanced out to increase the results to be able to compare with the other ones. And in healthcare, we have two scenarios: the patient room, where you can have patients that don't want to have this setting, but then they are taking resources that would be utilized for other patients. And about clinicians, this is very important, because if a clinician doesn't want to go into this because they only want to be under regular lighting conditions, it can happen that you have a medical error, and then who is going to be responsible, the healthcare institution or the clinician? So a lot of questions will arise in the future in the ethical field. And finally, this is a multidisciplinary domain. We should move closer to nature, because if we are close to nature, there is no ethical discussion. CCT is not the metric for human-centric lighting, and traditional tunable white is not human-centric lighting. It is about spectrum, not about color perception. Red, green, blue, and blue, yellow. Blue, yellow is traditional LED, are what I call fake news for our visual system. We have to begin to think about full spectrum or daylight light sources for human-centric lighting. Next point that is very important is that eye health, visual health is a concern. There is a pandemic now of myopia and age macular degeneration. And it looks that in the next 30 years, 50% of the population is going to have myopia. And because of all these reasons, the lighting industry has to take responsibility. So this is the lighting industry is not doing anything right now. And this is what I think is going to happen. Others will do it, and the lighting industry will face a very bad time with this. So we have to increase awareness, and we have to improve education in the field. And as for conclusions, the metric that I introduced, extremely important, the performance of the systems. And the lighting is not only light. We have to be very careful in extrapolating conclusions from basic science. The expo zone, we have to consider lighting as part of our health environment. The architectural spaces as the vehicle to get the light, and this is where well comes into place. Technology and design is not only about the light source, and the ethics. We enter here environmental, social, and corporate governance in institutions. So final, that nature is the model for human-centric lighting with sunlight and with darkness, because we forget about darkness. And the final one is that the only constant in nature is change. So don't think about human-centric lighting in a static position. And this is it, Alyson. So here we have reached the end of the presentation.
Thank you so much, Octavio. That was really great. We are actually right at the top of the hour right now, so we don't have a lot of time for questions. But if anyone in the audience has a question, please chat it over now. I think we got Octavio for a few more minutes to answer a few questions. And one that came in through Shirley, she wanted to hear a little bit more about the difference between alertness and awakeness, because some of the chatter we're getting in this industry is like, hey, retrofit your buildings with blue light and it's going to make everybody more alert. And it sounds like today you were just totally broke apart that myth and said, you know what, retrofitting with blue light is not human-centric design. So tell us a little bit more about the difference between alertness and awakeness and how human-centric lighting addresses that.
Yeah, this is extremely important, because you will read a lot about alertness, and when you are alert, you are, if you differentiate the stress condition that is basic in human health, you have eustress, that is the positive stress, and distress, that is the negative stress. What we want to promote is the eustress, the positive side of the stress, the one that keeps us alive and awake. But we don't want to promote distress so that you have to be like nervous and shaking your body. That is what happens when you drink a lot of coffee. When you drink coffee, you are alert, but then you are not focused. And my experience is that if you do good lighting, what you can do is stay on a more relaxed way and very focused in your work. You will have a better interaction with your colleagues in the workspace, and you will perform much better, especially because, and this is also a very important topic, because you will sleep better at night if you are not too much alert during the day, only when you have to be. You don't have to be like looking around you like the whole day. You have to be awake. So this would take us to another hour, but I think I thank you for raising this point because it's extremely important. Thank you.
You're welcome. And I think, again, it also highlights just the preciseness of terminology. And it sounds like today was a lot about understanding the best terminology. This is great. We got a few more questions coming in, and Pete wants to know about building types that are appropriate for this. I forgot to start out with a disclaimer that we are primarily talking about commercial office space today, because that is the primary application in well buildings. I know that most of your research is based in a medical hospital setting, but Pete is specifically asking about living spaces. So I assume you're talking about like your residential home. Pete, chat me over, let me know if that's correct. But Octavio, how do you see human-centric lighting being addressed in people's homes?
Oh yeah, it's extremely important. And this is also something that we have to differentiate. We have to differentiate between spaces where we are only going to be working and spaces like that are going to be only occupied during a certain time of the day, and spaces where we are going to sleep, and more precise, to live the 24 hours of the day. That can be like a geriatric or a hospital. And very important, places where we are going to sleep, they have a totally different treatment. So this is like the two kind of buildings that you have to differentiate: where you live or where you work, or where people work. But every space that has like a long-term presence of people should address circadian lighting design.
Okay, and so Pete is saying he specifically works with hotels, and so it seems like that is going to be the trickiest scenario, where perhaps you have overnight concierge desk clerks and then people sleeping. And I would just risk to say perhaps the answer is all of those spaces need to be designed independently, right? We can't just have one strategy throughout our entire hotel. We would have to look at the exposome, right? The populations that's using it, how much daylight is available when they're using it, right?
Yeah, in this sense, one of the topics that I have discussed many times is what I call competing lighting demands in a space. So you have different occupants in a space, and each of these occupant or group of occupants needs a different lighting, beginning with age. That is one factor that we always forget. So all people need a different lighting than young people. And of course, people that are, but as we said, we are not discussing here about shift working. So they need a different treatment. Hotels in particular are very difficult because you get different people from different time zones. But it is extremely important to consider like the average person that goes there, and that you have to change the light depending on the time of day, and that you should be able to provide different lighting in the room depending if it is day or night. This is when I travel a lot all over the world, and this is something that I always have to address in the rooms. You have to, because it's like a mess. This is like the most difficult thing, because hotels, most of them, they go for the cheapest, and they don't consider, because it's in the hands of the electricians, and they don't consider this. So coming back to what we said, this has to go into different procurement so that they value the proposition of human-centric lighting, and then we will have the right solutions. But of course, hotels are very important.
You're right. And I think it's just a tricky project type anyway about it, because of all the unique occupancy conditions. I'm glad you touched back on the IT thing. I think we'll let this be our last question. Kimberly wanted to get a little more clarification on how an IT professional would approach lighting design, because it's so far from their typical role right now. And you made two pretty bold statements there, saying that A, it's not easy for designers to even do this, and B, that MEP shouldn't be leading it. So I guess, in an ideal kind of way, how does the IT professional become an advocate for HCL and who can help that transition? Because it seems like that'd be a pretty big transition for our industry.
Yeah, I come from the IT world, from it's a long time ago. And at the beginning, in IT, you were able to do everything. And then everything becomes more specialized. So now you have people specialized in a bunch of different things in the IT world. And lighting, the way I see it, is that it's going to become part of the IT field. And you will need to work and collaborate with lighting designers, and this has to blend. So you will need IT people becoming familiar and aware about lighting, and lighting people moving into the IT to understand how to operate and commission all these systems, because it's not going to be the on-off anymore.
Okay.
So you have to work together, and this is why I said at the end that this is a multidisciplinary field where different people have to collaborate. So it's merging both how this is going to happen. It's not that the IT person has to become a lighting designer or that the lighting designer has to become an IT person. It's that they have to work together.
That's a really good explanation. That clears it up in my mind, and I think that's supported through the concept of an integrated project team and an integrated project developer, right? So coming in and saying, hey, maybe people are going to call this smart lighting, because I think that is where you're going with the IT integration, is that as we have smart buildings with human-centric lighting, it's not just about picking a bulb anymore, right? It's about designing that entire space. And I love how you showed us your lab, because that was a pretty radical change, right? It went from only overhead lighting to this totally indirect lighting. I mean, it really looks very different. And you really made it very clear that this is not an easy retrofit. This is a pretty significant integrated design change, and you even came up with your own circuitry, so I think if somebody wants to, if you're unclear about that, maybe think back to the laboratory design. And maybe my final question, this is one of my personal questions that came up when you were showing that circuit design and how there was 0% flicker, and that seems like a really amazing achievement. I know that I'm personally distracted by lighting flicker a lot. And is there anything, I guess, first off, how do you avoid flicker? And two, is there like a, what's the drawback? Like, why did you not want that in your environment?
Oh, you don't want to have flicker because we have evolved under the sun. And the moment that we get a signal that is perturbing our eyes, this is increasing our distress, because we begin to be alert because something is happening. And this is detected on the peripheral vision. So we see it more on the sides. And this is why if you go like into a retail space that they have usually very bad lighting, you will perceive flicker on your sides, not necessarily where you look to on the gaze, but on the sides. And this becomes very distracting, and it's a high perturbance for health. So how do you overcome it? First, with the LEDs have nothing to do with this. They are semiconductors, but are the drivers and the controls. So the main thing is that one of the fields that I'm promoting is DC grids. So to avoid AC, first step. And the second step is to do the dimming or the control in analog. Forget about switching, except if it is an extremely high rate. But the best way to do it is analog control with DC. And then you avoid flicker. This will, you will see this in the future. It's going to happen.
I feel like today's whole session was a little bit of future projections. I'm really excited to start seeing all of these things you've been showing us today in some actual well-certified and LEED certified buildings. So thank you so much, Octavio, for your time today, for being live with us from Miami, Florida. Looks like you got some great light behind you. I am tuning in from Atlanta. So thank you again. Lots of people are chatting that it was a great webinar, and you totally impressed me. I think we have to have you back so that you can teach us how to formulate an integrated human-centric lighting design team. I think that is the next step, is trying to figure out how do I actually bring the people together to make this happen in my building. So I hope you stay in touch with GBES and keep us up to date on your research. And to the audience out there, we will keep giving you more great topics like this. So thank you again, Octavio. Thank you for the questions. Hope everybody has an awesome day. You want to say bye to everybody?
Yeah, first of all, thank you, Alyson. Thank you for the invitation. And thank you to all the people in the audience for being there. And I hope that it has been useful for all of them and for you. And of course, it's a pleasure to be again here.
Awesome. All right. Well, everybody have a great end of your week and be well. Bye.
Bye.